Good afternoon everyone, something a bit interesting today. We've got a VE SS in. We're going to give everyone a bit of info on this system. So, backstory on the car. Customer had a tune done and a bunch of work done to it, mechanical work. Since then, or around the same time at least, we've had a battery light, so intermittent battery light, and charging system warnings come up and dash. Now, we've done a fault report on it. It is intermittent, doesn't happen all the time, and we've got a P0621 fault, which is the alternator L terminal circuit malfunction. Now, this L terminal on the alternator, this is a little bit of info on VE Commodore charging systems, because it's not a straightforward charging system. You've got an alternator here with two pulse width modulated controlled wires that run to and from the PCM. So this L terminal is this orange and white wire, and that is a control from the computer down to the alternator. So it's a 5 to 95% pulse width modulated signal. So that's what we're looking at on that. And the signal should look something like this. So this is a few seconds after startup. That's your alternator control. And if we go back to here, this purple and white wire is a 12 volt alternator output, which basically represents the duty cycle of the alternator. So this isn't necessarily a straightforward system, because from there to turn the battery light on, you've also got the ECM, which communicates between the BCM and the instrument cluster. The instrument cluster turns the warning light on and the error message when the ECM or the BCM detect an issue with this charge system. In that circuit, we've also got a current sensor in the back. We're not too fussed about this at the minute because it is reading fine on live data. So our next test, just to kill two birds with one stone, is we're going to hook the scope up to the alternator underneath the car. We're going to pin in at the alternator here and here, and we're going to check for our field control from the computer and our output. If all the wiring is good here, then I dare say we most likely have a alternator that's failing. So it is an aftermarket alternator. Apparently it's a decent part, but we're not sure of what brand's in there as of yet. We can't really see. So yeah, we're going to do that test and we'll get back. Right, so as you can just come around here, pinned into the alternator connector there, orange and white, purple and white wires. Nice straightforward. Hook that up to the scope. This is all a bit loose. This is one of the main harnesses that runs under, so that's just sort of been left loose, but our alternator control wires there run up to the ECU, so we're going to go from there. So we're just looking over our signals here now. This bottom one's an L signal, which should look like this. So this is our L signal. That's fine. That's our ECU controlled signal. Now this is the F terminal. This isn't what the fault's set for, but as you can see, the actual data, the actual packets in that pulse width modulated signal are a different size, and this is what we should be looking like this. And this is full load, which we're at full load, so we're at 15 volts. As you can see, so I reckon that this aftermarket alternator is causing this issue. Right, last video on what we got here. Red signal is our ECU control from the engine computer down to the alternator. As you can see, we're flicking the lights on and off and changing the load on the battery. This ECU control isn't changing, but we've got a terrible looking waveform, which is a field signal back to the ECU. So it goes bad here, it sort of comes good again a little bit, and then it just sort of starts to drop out and turn to crap again here. So that's just a crap alternator. Unfortunately,